Is my screen visible to all? Okay. So you were asked, you have to find a value k such that for any of these blocks, like this block or this block, whatever is the maximum of it, this k should be less than it. Okay. So basically, in this block, what will happen? Your k should be less than 7. In this block, what happens? K should be less than 4. If we write something like 4217, what happens here? In this one, k should be less than 4. And what happens here? K should be less than 2. So what we have to do is basically we have to find the smallest maxima that you can generate. Is that part clear? Like we have to generate the smallest maximum. Like whatever the smallest maximum is, that will be your answer minus 1. Basically, your answer will be that minus 1, something like this. So what you will observe in any of this is you don't have to check for more than two consecutive elements, AI and AI plus 1. You just have to take the maximum of this. Okay. So you might ask why. And if you see here, what will happen? If you have like a maximum of 4, if I add this into it, is my maximum changing? No, it still remains 4, right? Then if I add this, what is my maximum? It remains 7. If I just take these two, what will be my maximum? It will remain 4. And if I take these two, it will still remain 7. Similarly, if you check for this one, your maximum will be 4. If I add this since this is like the larger number, if I discard it, if I don't take this, if I make a group like this, here I'll get the smaller maximum, which is our goal. You add this one, doesn't change anything. Okay, if you add 217 or you take 17, you don't have to check more than AI and AI plus 1. Okay, that was the basic idea. You just store something like an answer and you just check the like something like this minimum of answer comma maximum of AI and AI plus 1. Is this clear? And like your answer, this since this is like the smallest maximum, your final answer will be this minus 1. Answer minus 1. Since your k should be less than the smallest maximum. K should be the largest value that is just smaller than this. Okay, so that will be the logic. Because we're looking for the minimum matchup using this ones. Yes, like the thing is, if you want, what will be your two options if you add something? Suppose like in 2417, if I have a maximum and this number, this is like greater than it, my maximum does not change. Okay, like smaller than it, the maximum does not change. But for suppose this area, I'll get a new maximum. My goal is to find the smaller one, right? If I check for this, if I check for this, want to find the smaller maximum. Okay, you don't have to check for more than 2. Okay, is this clear to everyone? pretty much everyone solved, like, right? Anyone who did not solve? Okay, then we'll move to the next question. This is like a very mathematical question. One thing you'll observe is since they have asked, like, what is the formula? AN equals to, like, you can write the AI equal to I XOR X and BI equal to BI XOR Y rather. Okay, so you have to find the longest sequence which will have the same values for some, like, you'll start from I plus 1, I plus 2. Let's say like this longest sequence is suppose till k. So I plus k, and you have to find another sequence somewhere from here. Let's say for your like A and for your B, this is not equal. Suppose you start from some j plus 1 dot 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 j plus k. Since like we are provided with the same I, and like this only difference you can see is this is what is making the main difference, right? This observation is this clear to everyone? These two will make our major difference. They will be like responsible for our answer. Okay. So what you will see is basically we have to find for some I or x is equals to j or y. Okay. So a prop like guys know what XOR does? Like what does XOR exactly do? Yeah. So basically, if you have 0 or 1, if your element, like if your bits are of the opposite type, it will give you 1. If they are of the same type, like 0 or 0, you will get a 0, or 1 or 1, you will get 0. Okay. So one property that you can see is x or x is equals to 0, right? Because all the bits are same. Yeah. Okay. So this is like your main observation. And then zeros or anything is just the number itself. Okay. This you like can use for a lot of stuff. Like some questions you might have seen, like those questions that one element occurs odd number of times, all others occur, let's say even times. You just XOR it, you will get an answer in like O of n. You just have to traverse the river one time, and you don't need any extra space. So that is like a popular use of XOR. So this is your observation. From this, can you derive this formula? Like if I have I XOR X equal to J XOR Y, you just check if I like if you do something like this, J or Y, these two will give you 0, and this two will give you just J. So you'll find J is equals to X XOR Y XOR I. Okay. This is a relationship between J and I. So let X or Y be K, something like K. Okay. So x or y is equals to k. So you can write j equal to k or y. Sorry, k or I. Okay. So we have to find a sequence, right? I plus 1. What happens when we have I plus 1? Then what do we get of j? J, like if you put I plus 1 here, what will you get? J, or rather like k's or I plus 1. It will be k's or I plus what is k's or 1? Just 1. Okay. So this is like an observation. And then what is this basically? This is just j plus 1. So you can have this whole sequence, right? K's or I plus 2 will be, you can write it as j plus 1. And then you will can like continue writing it. So what you will see is if you take this x or y, you will get a binary representation, something like maybe 1 0 1 0 0 0. So what does this mean? Like as we discussed, what does this mean? This means whatever XOR application we did on this, at this particular bit, the bits were same, right? Is that clear? If we get a 0 for this at some position, that means A of I, suppose A of I and B of j, at this particular bit, their XOR was 0. So you can say that these two were equal, right? Makes sense till here? J was like your second index, right? Where was it? Yeah. So we are denoting the index for B as J. Like we are looking for this, right? Where is it? Yeah. So we have to find a sequence. This sequence can start from anywhere, right? You just want them to be like same. No, both aren't supposed to be same, right? Like you can see in this case. Uh, okay, yeah, this is A, right? This is B. So here you will see, as they've explained, A is equals to 1, 2, 3 for like XOR equal to 0. Okay. And for 1, this is the sequence. Rather, let me see. Where is four? Okay, yeah. In this example, in third test case, they've shown if you take the XOR, you see from here you will get 41, 40, 43, 42, right? And here you'll get 41, 40, 43, 42. So you can see like, yeah, that's fine. So this can be any index, right? You can start from any index, but they should be of like the same length. They should have the same values and the same length. So what does XOR Y tell us? XOR Y tell us for suppose 1 0 1 0 0. This means your values were okay till here. Like whatever sequence you generated from this formula, your values were the same because we have like this equivalent equality from this equation, right? We have this formula, right? And from this we derived this, right? So till here, till this particular bit, all the values that were in your AI and BJ, they were the same. Okay. At this particular point, at this particular bit, you found out that the AI and BJ are no longer equal. Okay. Like after doing the XOR, you found this. So what can be the conclusion? So till this bit, you find your sequence was fine. Okay. Here you will till this bit, your sequence was fine. As soon as I reach here, there is like a difference. Both of them are not the same. Okay, these two are not equal anymore. So this will be your length of the sequence. I think yeah. Okay, like for this particular example, like the example that we took, two two cube will be your length, and like it won't be three because like three is not your AI and BJ, right? You are checking for the bit representation. So if you write AI equals to something like 1010, and you will write BI equal BJ equals to 1001, something like this, you will find like whatever like this is the like let's say 1010, yeah. Let's say like you will get a XOR 1 here, right? So like check it in your copy or like dry run it, you will find that 2 to the power 1, that will be the number of elements which had the same bit after zorification. There were only like two elements which satisfied our criteria. Okay. Like what happens in XOR, right? Like in XOR, your this particular bit, suppose 0, 0, 0, 1, and you have something like 10, and you have something like 11, 0, 0, 0, 0. Okay, suppose these two were our values. So we'll find that these many like numbers who had a bit here, they had like the same bit representation. Like for one number, this number I and j, when you write that bit representation, you'll find that they had this bit was same. Then like all the numbers that were in this range, they had this bit as same. Then you move to this bit, you'll find again they had all the bits same. So like what happens in a bit? Bit is like 2 to the power bit, right? This is like your shift, right? Binary representation. What happens in a binary representation? In a binary representation, if you shift by 1, that is actually shifting by 2, right? Yeah. So that is actually the observation. You will find like if you had a sequence and you went till I plus p, you will find that till this particular bit, because like if you write 100, suppose it was 10, then it will be 1001, or it will be something like 10010. So you have to find whether this bit was set or like did they all share the same binary representation till this particular bit. If they had the same binary representation with this one till this particular p bit, then the XOR will also be same. Like the XOR will be 0. Hello, am I audible? Hello, am I audible now? Okay, okay. One second, I'll share my screen and then screen. Share. So I was saying at the till which part did you guys hear? Like, can you tell? I'll start from this part again. So suppose what happens is you will write some binary representation for this, right? These two. When will these two have the same like this value from this condition? Uh, from this formula, we wrote this formula, right? When will this be valid? If they have some binary representation, which when you XOR, you'll get this. Like these two will be equal. Okay. So this, yeah. So you just like check till which bit these two had the same binary value. You can check that by checking how many times XOR was 0 till you encounter your first one. So that means at this point, the binary, like this whole formula, this one, j equals to k XOR I, this particular one failed. Okay. Like when I XORed it with this, my I didn't get this because at this particular representation of I for some 1010, let's say 000, you XORed it and you got 0 0 and you got 1 and something something, we don't care about it. We found that this was the maximum point in our binary representation of I, since I is what I is like from starting from 0, right? And you can like write it like this. You can keep writing it like this. So you will find like what will happen 101. Somewhere along the line, you'll find that this formula failed. So you have to find at that bit, at which bit that happened, and 2 to the power that particular p, that will be your answer. You can like cross verify it when you are, yeah. So we increase I by 2 bit. Yeah. So like your XOR is basically checking till which bit your formula was valid. The moment you found that we can no longer XOR it at -0, that means that the binary representation of all the values in that particular range, that is like the max limit that you can like verify. You like solve some questions on XOR, we will share the resources. We might like try that. Okay. So then we can have a further discussion. If you face any difficulties in that, you can like inform to us in the WhatsApp group. But like study some properties of XOR and solve some questions, you'll get like a better idea about the representation. Okay, how you're using this bit observation. Okay, so study this XOR part again. We'll like if you still face any issues, we can like resolve it. Okay, am I audible to everyone? Hello. Yeah, the oh, is it clear now? For now, like there's some issue with the internet, I think. Now it's clear, right? So I'll move on to the next question. Is that fine? You guys like read a bit about Zor. We'll be sharing the resources. I think there were some resources that were okay. Yeah, like if it's cracking, tell me in the chat, or you can like unmute your mic and inform me. Okay, I'll repeat after that part again. Okay. So I'll move to the next question. Is that fine? We'll share some resources about Zor as well. You guys can also practice. Okay. So C is like very mathematical question. So what do you is what that actually is? You want your into AI to be greater than the sum. Summation of AI. AI is the value of the coin you're investing in. This is your main function. Okay. So what you can do is, let's say, how do you read AI? You have to find sequence AI. You have been offered to again if there are n outcomes, and for each of them they must bet some amount of coins. In the event that 10,000 you will receive back the amount of coins equal to your bet on that outcome multiplied by ki. Ki is your multiplier, right? Is this clear? Like, was there any doubt in the question? Uh, hello. Audible right now. Explain and I like. Can you guys hear me now? Okay, okay. Yeah. So I'll go through the question once more. Okay. So what they ask is you have there's a game which has n ones. Okay. So in probability that one of your i's from like I equal to, let's say, some 1 to n, if one of these i's you win, you will receive ai into ki. Hello. Am I audible? How do we get minus when they said, right? In your else condition, if you there does not exist any such possibilities, you just output -1. That you're like the original sum that s by ki1. If you take that, uh, what you'll find, like if you just like run it and you, uh, what should I say? If you take the sum, there will be a possibility, right? That some if when you do integer divisions, like it might be less than like what you expect. Like sometimes for 5/2, if you do an integer division, you will get 2, right? So that one is lost somewhere. So that means there will be some possibility for which you can like get and that you might not earn a profit, right? You have to find the optimal sequence, and the most optimal sequence you can get is when you have like an LCM, right? So that is like why you're getting -1. You have like your original S, right? That you get from this, like you keep adding this and you'll get some S, right? S plus equal to LCM by KI. If you find this is not, this is like less than LCM, you'll be like, okay, I can find the sequence. Otherwise, you can't. You can't -1. And that's the thing, right? If you, uh, what happens is like if you after taking your LCM, you will like check with KI. It should be like divisible by KI, but for like some values of KI, you are not getting it. Like AI by KI is coming out to be something that does not satisfy your condition, right? So you divide that and you'll find that it is not less than some. Or something like you have like a very large value and like you take the LCM of it and you find that the sum is not coming out to be it is like what happens in LCM is in LCM some of your factors might not be repeated for like something like what should I say, for 2 comma 4 what you will get, what would be the LCM? It will be 4, right? But for some case, if I have something like an 8, so even if I get 2 plus 4 or something like that, that will be less than 8, right? So in LCM, all of the multiples are not considered, right? Like run it, like do a dry run of it for like the no cases. Let's see, 55555. So for 55555, what do you think is the LCM? Five only, right? Yeah. So if you do that with the 5, if you uh, like do some divided by 5, what will you get? You'll get like it should be strictly less than your LCM, right? So what you'll get actually 5 less than 5. That is not true, right? You want it to be strictly less than your LCM. This is the only time you can earn a profit. Otherwise, it will be equal to 0 or it will be less than 0. From the formula only, right? As that LCM part. Let's see other case. 632. Understood, or should we check? So that part is clear, right? Or should we like discuss 632 as well? Like for 632, what you will get? You will get LCM as 3, 2, you will get 6, 6 and 6, 6 will be the LCM. And 6 by, again, you will get the same case, you will get 6 less than 6. That is again false. So you can't earn a profit in this case as well. Okay, like they gave us this condition, right? It should be strictly less, like they highlighted is strictly less than the number of coins. So you should always earn a profit. Your profit should be greater than zero. That is the condition. Is that clear?